Hi everyone. This course is all about machine learning. So in the later classes, I'll be explaining you about artificial intelligence, machine learning, deep learning, and data science. So we'll see one by one. So in this video, I'll explain you about machine learning and where we are using this machine learning and what are the applications. And I'll little bit explain you about the data sets. Okay, yes. So now we will move on to the concepts of machine learning, and I'll start with the definition, right? Yes. So see, today it's a digital era. Everyone is talking about machine learning. What is this machine learning? Yes, as per Herbert Simon, he is telling that learning is any process by which a system improves performance from experience. Yes, I know what you're thinking. As a human, right? We are learning from our experience. Like this, computer is also learning by its past history and experience. Right? So that is machine learning. Yes. And one of the topmost machine learner whose name is Tom Mitchell, in the year 1998, he have defined what is machine learning is. Yeah, so machine learning is the study of algorithms, and he's telling that it is PTE, right? What is this P? Improving their performance. What is T? At some task, right? And task is defined by us, and according to the task, it will try to this machine learning model will try to improve their performance, and then what it will do, it will learn from the past history, that is from the experience, that is E, right? So this is what Tom Mitchell is coined about the word machine learning. Yes, now I'll be explaining you about the difference between traditional programming and the machine learning. So it's a clear cut difference, right? Yes. In traditional programming, what are the inputs that we are going to write or we are going to give? One is input data, and then we'll be writing the program, and the computer will process on that, and then the output is produced. What is this data? Data is the input data which we are given, right? So for example, if I want to if I want to add two numbers, for example, a equal to 10 and b equal to 10, yes, I need to write some C program or C++ program or Python program, whatever maybe, right? So I'll be writing a program. I have to declare A and I have to declare B, and then I need to write the another variable C is equal to A plus B. So what this program will do, this program will add these two numbers and it will give you the output. So what is the output? Output C is equal to 10 plus 10, it is 20, right? Yes. So this is the actual traditional programming method. Yes. And how this machine learning differs? What is this machine learning? It's very simple. The input is given, output is also given, right? So as a human, we know what is the input and what is the output, and both will be given given to the computer. And what this machine learning will do, depend upon the input and depend upon the output, it will model itself, and it will try to classify, and it will try to learn from the past data, and then it will classify correctly, right? So it will model itself, right? I hope it is clear for you. Yes. So for machine learning, the input data will be given, the label will be given. The label can also be called as output, response, or label, right? Input is given, output is also given, and then the machine will try to model itself. That is machine learning. I hope it is clear for you, right? Yes. The next question arises into our mind, that is, when do we use machine learning? Yes, when do we use, right? So ML is such a great uh, word that is called machine learning. ML is used when human expertise does not exist. So, for example, if you take, if I want to process the data which is available in the Mars, so what can I do? I cannot go there and I cannot process the data. I cannot observe the data and I cannot process, right? So, in that case, machine learning plays a vital role. Yes, I hope it is understandable, right? Yes. So this machine learning is used when the human expertise is not able to exist over there, right? The second beautiful example is if a human can't explain their expertise. So for example, so I know I'll be able to recognize my father's voice. I'll be able to recognize my mother's voice. I'll be able to recognize my children's voice, right? Yes, but I don't know how I'm recognizing. What are the features that made me to recognize? I don't know, right? Yes, in that case, if I'm not able to explain how I'm classifying or how I'm expertising in that, so in that case, yes, machine learning plays a beautiful role. It will recognize very correctly. Yes, so very beautiful example it is. Yes, and we should know the growth of machine learning, right? What is the growth? It's tremendous growth in this digital era. This machine learning is preferred approach to recognize the speech, to recognize the images, to recognize the videos, to recognize the text, and in natural language processing too. Yes, and probably in robotics and automation, right? In robot, the main algorithm which we are using is machine learning. Okay? And in computational biology, right? So we'll see one by one in later slides or in later classes what are the applications that we are going to use this machine learning in those applications. Yes, and I would like to tell you a beautiful example of the classical example of where we are using this machine learning. Yes, it is possible for you to recognize the handwritten digits because to classify or to recognize handwritten digits is very difficult. Yes, for example, if you see in this slide, if you take, if you want to classify this number 2, it is very difficult for a human to classify which number is 2, whether this one or this one or this one. It is very difficult. But if you train a model or if you model, if you try, if you are able to use a model for this particular application, this machine learning model will classify the handwritten digit to very correctly. Yes. So we'll see all these examples by using a Python coding in the later classes. Yes. And I would like to tell you some more examples of tasks that are best solved by using a learning algorithm, right? I'll tell you what are the kinds of learning algorithm which is available. I'll explain you. Yes, here some of the examples are, as I told you, the recognizing the patterns is very important example of this particular ML task. Yes, in recognizing patterns, we are recognizing the face, we are recognizing the facial expressions, right? And we are recognizing the handwritten digits, and we are recognizing the spoken words. And this machine learning model will tell you how the human mentality is, whether he's happy, whether he's sad, and whatever may be the thing. It is possible for a computer to tell, right? It is very amazing, right? Yes. Next is for medical images. Okay, so it is easy for the doctor to diagnose the disease if they use this machine learning algorithms. Yes, and then the second example is generating the patterns. Yes, it is possible for generating the images or generating the motion sequences. So it is very useful for video making or film making, whatever it be, right? And then the third beautiful example is recognizing the anomalies. Yes, it is easy for us to, if we use this algorithm, it is easy for us to identify the unusual credit card transactions. It is very difficult, right? Yes, it is possible for us to identify that and unusual patterns of sensor readings in a nuclear power plant. so that it is easy for us to predict or to take prevention over there. Yes, yes. The next beautiful example is prediction. Yes, using this AI model or machine learning model, it is easy for us to predict the future stock prices or currency exchange rates. Yes, yes. So I can tell you what is this machine learning in a nutshell. Yes, yes. So many machine learning algorithms are available. For example, tens of thousands, and in every month or every day, a new algorithm is emerging. But the common thing which the algorithm will be having is every machine learning algorithm has three components, right? One is representation, second one is evaluation, third is optimization, right? So in this representation, we'll be looking over into so many topics. We'll be dealing with the decision trees, set of rules, instances, graphic models like bias model and Markov nets model, and a beautiful concept we'll be seeing in the later classes, neural networks, support vector machines, and model ensembles, etc. These are called representation models, right? And what is this evaluation? So whatever may be the kind of thing, we need to evaluate, right? We need to provide a feedback, or we need to evaluate how the system is performing, the performance models, right? So for this evaluation model, we are going to see the available models like accuracy, precision recall, squared error, minimum squared error, likelihood ratios, posterior probability, the cost, the utility, margin, entropy, KL divergence, etc. Yes, we are going to see all these evaluation models and its mathematical formulas in the forthcoming videos. Yes, and the thing is, last component is optimization. So each and every system has its own optimization method. So in this optimization method, we'll be seeing about combinatorial optimization, convex optimization, and constraint optimization. Right? Yes. Yeah, this is a very important part. Types of learning. What are the types of learning algorithms that are available? Right? Yes. So supervised learning, unsupervised learning, semi-supervised learning, and then reinforcement learning. Right? So I'll tell you in simple words what is supervised learning. In supervised learning, input is available, output is also available. Then we are going to model it, right? So training data includes the desired data output is called supervised learning. Now, for example, if you take a teacher, in the presence of teacher, right? So in the supervision of teacher, we are going to write the exam. So that is called supervised learning. Yes. So many algorithms includes in the supervised learning. And then the second one is unsupervised learning. So what is this unsupervised learning? The input is available. The output is available, but it is not labeled, right? So for example, we need to group the output, or we need to cluster the output. So for that, we have to use this unsupervised learning. Yes. And then semi-supervised learning is the third one is semi-supervised learning. In this semi-supervised learning, some of the data is available for supervised and some of the data will not be available. And it has to be modeled through unsupervised learning. Right. The last interesting learning algorithm is reinforcement learning. Through the rewards and actions, we need to train the model. So that's why we are calling this reinforcement learning. Right. So for example, if a child is learning, I'll be awarding some with some chocolates or gifts. It will try to learn more, right? So that's why we are calling this as reinforcement learning.